Good morning, my dear student. Welcome to my YouTube channel. Today we will see some problems on RLC. Okay, let's start with this problem. A 100 ohm resistance is directly switched on across a 10 volt battery. What is the current through the resistor? How much is the power loss? Also find the energy consumed in 5 seconds. Okay, solution of this. First, we have to write down the given data. That means resistor R equal to 100 ohm. Given voltage source 10 volt. Another current through the resistor, we know I equal to V by R. Simply 10 by 100, which equal to 0.1 ampere, which equal to can write 0.1 into 10 to the power 3 milliampere, which is equal to 100 milliampere. Next question is how much is the power loss? We know the power loss formula. Power loss P equal to current through it I square into total resistance. I square means 0.1 is the I square into total resistance 100. 0.1 means 0.01 into 100, which is equal to 1 unit is watt. Next, energy consumed. Energy consumed, which equal to E equal to, we know energy is equal to multiplication of power with time, I square RT. I square R is 1, time is given 5 seconds, which is equal to 5 joules. Energy equal to 5 joules. Next we will see another question. So this question, solution of this question. What is this question means? The strength of a current in a 1 Henry inductor changes at a rate of 1 ampere per second. That means di by dt, which is equal to 1 ampere per second. Inductor is L equal to 1 Henry. Find out the voltage across it. Okay, the formula for voltage VL is equal to L di by dt, which is equal to L is 1, di by dt also 1, which is equal to 1 volt. Next question is determine the magnitude of energy stored in the inductor after 2 seconds. Energy stored after 2 seconds. We know energy stored W, which is equal to half L I square, which is equal to half L is 1, I square equal to 2 square, which is equal to 2 joules. Equal to 2 joules. This is the next question. A capacitor has a capacitance of 5 microfarad. C equal to 5 microfarad is given. Calculate the energy stored in it if a DC voltage of 100 volt, V equal to 100 volt, is applied across it. We know energy stored in a capacitor. Energy stored in a capacitor. Capacitor E, which is equal to half CV square, which is equal to half 5 into 10 to the power minus 6. 5 microfarad can write 5 into 10 to the power minus 6 farad. So 5 into 10 to the power minus 6 into V 100 square, half C V square. After calculating this, we get 2.5 into 10 to the power minus 2 joules. Next question is the current and voltage profile of an element versus time has been shown in below figures. Determine the element and find its value. From this element at zero time, the current per time is 0, but voltage is a constant voltage 2 volt. But after 5 millisecond, current becomes 1 ampere. At that time voltage becomes 0. That means at t equal to 5 millisecond, voltage across element 0, current I 1 ampere. At time equal to 0, voltage equal to 2 volt, current I equal to 0 ampere. That means at a 0 time, that is at 0 time voltage appears, current is 0. That means it is open circuited. At 0 time it is open circuited. But at 5 millisecond, we can say at a steady state also. At steady state, we can say at a steady state voltage equal to 0, current flow is 1 ampere. That means this property shows an inductor. This property indicates an inductor. That means the element is an inductor. Now find its value. From this, di by dt is 5 into 10 to the power minus 3. At 5 millisecond, ampere is 1 ampere. So change in value current with respect to time, I can write 1 by 5 millisecond, which is equal to 0.2 into 10 to the power 3 ampere per second. Initial voltage across ET, V equal to 2 volt, initial voltage. So we know V equal to L di by dt. From this, L equal to V divided by di by dt, where V equal to 2, di by dt 0.2 into 10 to the power 3, which equal to 10 millihenry. We'll see next question. This is the next question. A 50 microfarad capacitor, that means the capacitor value is 50 microfarad is given, is charged to retain 10 millijoule. That means energy equal to 10 millijoule is given of energy by a constant charging current of 1 ampere. That means a charging current I charging equal to 1 ampere. Determine the voltage across the capacitor. That means Vc is equal to how much we have to determine. We know energy stored in capacitor. Energy stored in capacitor E equal to half CV square. Okay, from this equation V square we can write 2E by C. Can write 2E by C, which simply can write V equal to 2E by C root over. Putting the value of this 2, the value of E is 10 into 10 to the power minus 3, 10 millijoule, divided by C. The value of C is 50 into 10 to the power minus 6, root over of this. Which I can write simply, this will become, we cancel out this will 10 to the minus 3 will remain here. Okay, 20 into 10, if we take this numerator value, denominator value to numerator 10 to the power 3, here is 50, root over, you can write here 2, 1, 10, this much of value divided by 50, root over, when we cancel, which is equal to 400, root over of 400, which is equal to 20 volt. That means the voltage across VC 20 volt.